Hey everybody, my name is Alex Merced, and welcome to this presentation, Data as Code. Project Nessie brings a Git-like experience for Apache Iceberg Tables. Now, before we get started, let me tell you a little bit about myself. I'm a developer advocate for Dremio, the data lakehouse platform. I travel around and talk about data lakehouse at events like Data Day Texas, OSACon, here at the Move Data Summit, and many more events, and work for companies like Crossfield Digital, Campus Guard, General Assembly, and many more. I'm also currently working on writing as one of the co-authors of Apache Iceberg, the Definitive Guide, the upcoming book from O'Reilly on the Apache Iceberg table format. You can scan this QR code for an early release copy. Also the host of several podcasts, which you can subscribe to on Spotify and iTunes, all about data, data lakehouses, data movement. If you like hearing data and talk about data, subscribe to any of these podcasts, and also write a lot of blogs over there at dremio.com/blog. And actually, recently we just published a blog about creating a data lakehouse using tools like Airbyte with Dremio. So I highly recommend heading over to dremio.com/blog and reading about how to construct a data lakehouse with Airbyte and Dremio. But in today's presentation, we're going to be talking about how a open source technology, Nessie, is bringing some new features, some new possibilities, not just the data, but the data lakehouse. So that begs the question, what is a data lakehouse? And at the end of the day, the data lakehouse is just a data lake, which is just a big repository where we store all of our data that's open and accessible anywhere. We just take that storage layer and we're going to inject a new layer that includes a table format like Apache Iceberg that allows us to treat all those data files as individual tables, and a catalog that allows those tables to be bundled together and brought to all our favorite tools. Okay. And when you add that table format and catalog layer, you now enable a much more database type interactivity with your data lake. It feels more like a data warehouse, more like a database, thus the term data lakehouse, making it possible to treat your data lake as a center of your data universe. And there's a new trend when it comes to this sort of data lakehouse world, and that is data as code. The idea here is when it comes to the world of software engineering, they deal with many of the same problems we deal with data, such as quality, dealing with code quality, with tracking different versions of code and things like that. So as we try to overcome these challenges of quality and versioning here in data, we want to borrow from practices that have already figured out these problems, particularly the practices in software development. And that's what data as code is, taking concepts like CI/CD, continuous integration, continuous deployment, taking versioning and whatnot, and applying it to the data world. And today I want to focus on the world of versioning, which just means tracking different versions of things. And generally, every time you track the changes from point A to point B, we call that a commit. Okay, and there's different ways you can track commits in the data world. And oftentimes we may want to track different branching trails of changes, kind of like having different forking versions of a story. Okay, everyone's been really enjoying like the multiverse and like Marvel and everything everywhere all at once. Imagine a multiverse for your data. Okay, and that's referred to as branches. So these are the possibilities that versioning brings, and there's different ways of versioning your data, whether it's by capturing the changes in your files, capturing changes in the metadata of one table, or capturing the changes in the metadata across multiple tables. And we'll talk more about that. But what are the benefits of being able to track changes in my data? Well, being able to create multiple branching changes of my data allows me to do isolation. So that I can create a branch, do all my changes to my data on a branch that's isolated from all my end users who are querying my data. So that way, once I'm done bringing the data in and testing its quality, I can then publish all those changes simultaneously. It allows for no copy experimentation. Oftentimes, we have to make duplicate copies of our data to create different environments for experimentation, for development, and that can get really expensive storage-wise. And sometimes not necessarily get us the exact level of testing and access to production data that we'd like. So with versioning, we can create multiple branches where people can experiment with production data without affecting production use cases, and with avoiding all those storage costs of creating multiple copies. You could possibly do multi-table transactions, because if you can isolate the changes across your multiple tables onto a branch, you can then publish the changes across multiple tables, simultaneously. Rollbacks. Since I have a history of all the changes to my data, I can then roll back to those previous changes which makes disaster recovery a lot less tedious. So instead of spending a weekend backfilling data, I just roll back to the last clean commit and rerun the job. Reproducibility. Oftentimes we need to run analytics against old versions of the data. And oftentimes what we would do is we'd end up creating like these snapshot copies, and we create a copy of the data at certain points so that we can go back and test against those old points in our data. Instead of having to create copies of the data, we can just tag certain commits so that we can run our analytics against a version of the data, not a copy of the data. And all of this enables better ability to test for data quality, data consistency, data validation, because we're able to basically isolate our work and allows us to take the time to run those data quality checks, those data validations, to make sure that our data is of the best quality possible, because who doesn't want good quality data? It means better insights and better value for your business. So Nessie takes the whole idea of versioning in a very interesting and unique direction. Instead of versioning the different files that make up your tables, instead of versioning the metadata of a single table, what it does, it versions your entire catalog of tables. When you're working with specifically Apache Iceberg Tables, each table generally has like this master metadata file, this one metadata file that allows an engine to kind of reconstruct a particular state of the table. So basically what Nessie does is it tracks what that metadata file is for each of your tables, each of your Iceberg tables. So each commit is really a list of all your tables and their metadata file. So anytime that metadata file changes, it's going to create a new commit, a new snapshot of the catalog, and those commits, just like before, can be branch into multiple versions or different histories of that same table or that same catalog. And this kind of enables a whole new paradigm, because you're no longer thinking about, hey, which files. You're thinking about my table, my catalog, and being able to work with my catalog as a whole, and everything kind of gets into this sort of multi-table paradigm. You get into multi-table versioning, which allows things like multi-table branching. Instead of having to create a branch for each individual table, which you can do with just Iceberg by itself, you can create a branch for all your tables in one operation. You can merge all the changes across multiple tables in one operation. You can tag the state of the data as it was in the past in one operation. You can roll back all your tables to as they were before disaster happened in one operation. This Nessie technology is open source, which allows it to be flexible, allows it to be customizable, and it's going to allow it to be very interoperable as an open standard. And if you don't want to deploy your own Nessie server and manage that and maintain that, there is a cloud managed service. Dremio has its own sort of cloud managed version of Nessie called Dremio Arctic, which allows you to get all the benefits and then some, such as automated table maintenance and a really nice UI for managing your catalog for free. Just go sign up at Dremio, and you now have a Dremio Arctic catalog that you can use with your favorite tools like Dremio, like Apache Spark, Apache Flink, etc. It's cloud agnostic. So when you're using Nessie, you can use it with Azure, you can use it with AWS, you can use it with Google. It's storage agnostic. You could be using object storage with your favorite cloud provider, or you could be using like a Hadoop HDFS. It's all up to you. It's just a catalog tracking your tables. And it comes with its own set of access control and cleanup features to make sure that even though you're managing all these multiple branches of your tables and your catalog, it can still identify which data files you no longer need and clean them up for you. So Nessie brings a lot of new features to the data lakehouse and really enables sort of this new world. Okay, and it's a topic that I love to talk about, and you can hear me talk more about that over there at the Dremio.com blog at dremio.com/blog, and then many of the podcasts that I host, such as Gnarly Data Waves, In the Grand Scheme of Things, Data Nation, and Select Star from Data Lake. Thank you all for having me here today at the Move Data Summit. I'll see you all later. Have a great day. My name is Alex Merced, developer advocate at Dremio.